In this video lecture, we're going to examine an easier way of parsing strings using an existing string API method together with an array of strings. Okay, let's get started. Think back to an earlier program assignment where you needed to manually parse up a comma-separated string using a handful of string API methods in combination. It was a bit tedious to do that, wasn't it? Doesn't Java provide a better way to do that? Well, of course it does. As it turns out, the string class API also provides a dedicated split method, which can be applied to an existing string object to parse it up on some specified delimiter character or pattern. The reason we didn't use this 8 weeks or so ago was that we hadn't yet learned about arrays and for loops. And besides, at that point, I wanted you to gain some familiarity with some more basic methods of the string API. But now that we have learned about arrays and loops, here's the interface for the string class split method. This is taken directly from the API, and you can look at the details there. It's color-coded here for your viewing pleasure. If we have some existing string object, string obj, shown here in green, we can then apply the split method to it with the usual dot notation, shown in blue. The split method takes as its input some string delimiter character or pattern, shown in red. What it then returns is an array of strings, shown in purple, and as you've probably already guessed, those array elements are the ordered list of substrings of the original string object. In a sense, this is kind of like what we've already seen for the main method command line arguments. The advantage to us is that one statement like this can replace what we previously did with one entire program. In fact, let's see an example of this on the next slide and the ones which follow. You might not like seeing this first simple example because it reduces an earlier program assignment you did to one simple statement. Here we're initializing a string that we want parsed up and we call it input. Then on this next line, we simply apply the split method to this existing string, specify that we want to use the commas as our delimiters, and split parses up this string and returns to us this array of strings called data, which is visually depicted down here. This array of strings called data has 5 elements, each one a string, with these last 4 elements also incorporating some leading whitespace. So maybe we want to clean these strings up a bit by trimming them. In this for loop up here, we loop over the entire array as usual, and we print out the one-based ordering of the substrings and then each of the substrings. But notice that each array element data sub I is itself a string, so we simply apply to it the trim method to remove this leading whitespace, giving us this output shown here on the bottom. I believe this substring 3 is the one we were after on the earlier assignment, so it would be the trimmed data sub 2 array element, and we've gotten to it by using only a line or two of code this time. I think you'll agree that this is a much preferable way of parsing up some string, right? Please take a moment if needed to pause this video and view the short code walkthrough for splitsimple1.java, which you'll find in the usual place. Open up this file in JGrasp so you can follow along, then come back to this video when you are finished. In this next example, we'll take the split operation a little further by also performing some data conversions. Let's say we start with this data string highlighted in yellow. We might not know where this came from. Maybe it was read from a file or extracted from a database, but it contains some item name, an inventory quantity, and a unit price. And let's say we want to calculate the value of this inventory. This string sure looks like it's comma separated, so we'll apply the split method to it using a comma as our delimiter, which gives us this array of strings called data, which we see depicted in this first step on the lower left. However, we notice that our substrings have some leading whitespace that needs to get cleaned up. So in this for loop over here, we loop through the data array, trim each element, and write it back over itself, giving us this next stage of refinement we see down here in the second step. Notice that these are all still strings at this point. If we want to do any calculations with these last 2 elements, we need to break this array into individual variables and convert these last 2 into numbers, as we do in the next few steps of our code. We assign the 0th element to its own string variable, then use the appropriate wrapper class methods to convert data sub 1 into an int and data sub 2 into a double. And we also assign these to their own named variables, as we see in this last step at the lower left. We now have an item string whose value is widget, an inventory int whose value is 30, and a price double whose value is $2.99. With these individual scalars now in hand, we can perform this inventory calculation and print out the item name and this 2 decimal place formatted result, giving us this output we see here. To see this code execute in a little more detail, please take a moment if needed to pause this video and view the short code walkthrough for splitsimple2.java, which you'll find in the usual place. Open up this file in JGrasp so you can follow along, then come back to this video when you are finished. In this next example, we're demonstrating how to perform a 2-level split on some input string and convert it into the data for some new object instance. At the top of this code on the right, we see this 3-line main method client. Let's say we have all the data needed to instantiate a new person object in this one string. We pass that string into this createPerson method. It does its thing and returns a new person object P, which we then print, giving us this output down here on the left. The real guts of this program, and the interesting part, comes from this createPerson method below. For starters, notice that it's a static method, which it must be because it's called directly by the static main method. Then look at its interface. It accepts a string as input and returns a person type object to its caller. Although this may be the first time we're seeing it, there's absolutely no problem with that because methods can also return data of any class type. So after these declarations, what's happening here is that we're making a primary split upon the input string using a comma as the delimiter, then trimming the resulting string array elements as before. That converts this input string we started with up here to this string array we see here on the left. But notice that the date itself contains 3 /delimited fields, so we then perform a secondary split on this third element of the string array, as we see in the code here on the right. The third element of the tokens1 string array is tokens1 sub 2, and it's a string itself. We perform this secondary split, but this time using a slash as the delimiter. Once again, that gives us this second string array tokens2, which we once again clean up using trim in a loop, and we wind up with the second string array we see here on the left. Now we have all the individual scalar data we need to instantiate a new person object. We just need to assign it to individual variables as before, and perhaps also make some type conversions to ints or doubles using the wrapper class parse methods as we saw before. So going from top to bottom in this code versus these 2 string arrays on the left, the first name is tokens1 sub 1, and the last name is tokens1 sub 0. And notice the specific ordering of these versus the string array. The gender is the first character of tokens1 sub 3, and we grab the first character of it using char at 0. The height and weight are tokens1 sub 4 and tokens1 sub 5, and we need to transform these into doubles using the wrapper class parse method as seen over here on the right. And for the birth date, now we make use of this secondary string array tokens2, but we have to convert the 3 string array elements to ints, as shown here on the right. Then we use those 3 resulting int values to instantiate a new CS12 date object for the birthday. Once we have the 2 names, gender, height and weight, and birth date, all broken out into dedicated variables or objects, we then use them to instantiate a new person object, which we return to the caller, and it is printed up here in the client code, giving us this output we see back down here. So summing up, we've taken this one starting comma-separated string from whatever its origin, passed it through this method down here, and transformed it into a person object we can work with, a string to person object transformation. And we'll use the static method which does this in the next example. Please take a moment now if needed to pause this video and view the short code walkthrough for splitperson.java, which you'll find in the usual place. Open up this file in JGrasp so you can follow along, then come back to this video when you are finished. In the previous example, we demonstrated the steps needed to transform one comma-separated string's worth of person data into one individual person object. And fortunately, we carved out all those steps into a self-contained method called createPerson. Now we're going to use that method to process an entire text file's worth of input data. As we see down here on the bottom left, we're starting with a text file where each line will represent one eventual person object, and we'll read that file line by line and transform each line into one person object, as we see here on the right of this process. Our text file will look something like this on the upper right. Each line represents one person object to be created, and in order the comma-separated fields are last name, first name, birth date, gender, height, and weight. Clearly, This would be the preferred approach if we needed to import lots of data records, each having lots of individual fields. So here's the source code which will read that file and cycle through it line by line and create a person object from each line. I'm going to defer most of the details of this to the code walkthrough, but as a quick run through, notice that we're prompting for a file name using our utils file read string. Then we use that file name to set up a file-based scanner object file input. Then in this while loop, as long as there are still lines to be read, we read one full line of text, then feed it to our previous method, which we are calling statically here. It returns a person object from that input string, and here we simply print it out. For example, here's the person object created from this last line of text in our input file. In this example, notice that we're simply overwriting the person object p each time because we are only printing it. But it wouldn't be too much of a stretch to create an array of person objects and add each created person p to that array. We may see how to do that in an upcoming example. To see this example in more detail, please study the short code walkthrough for split person file read.java, which you'll find in the usual place, and follow along with it in JGrasp. Okay then, and that concludes this lecture video on parsing using 1D arrays.